Hello. Okay, so let's start our today's lecture. As they already mentioned, today's topic is basically how to overcome some limitations that deep learning has in production, and how to do that with some classic techniques which are still there and which we still have to use. Let's start at the beginning. The real question now is, why are we still talking about everything about AI, and why everything is still not solved, and what kind of problems basically do we still have in real world? So one short clip about how we see AI basically in today's world. There is no audio, but you will see enough. So basically, for my perspective, you know which one the AI is. And we still have some other systems that are there and that are still running, and they are basically doing most of the work. Who am I and why are we talking about this subject? Basically, as they already mentioned, I have a PhD in computer science. I got my PhD in artificial intelligence and optimization, which is something that I have been working on for a few years right now. I'm working as an assistant professor at University of Sarajevo, but at the same time, I have published more than 25 research papers, mostly in the field of AI. And what's happening there is that from the beginning of my career, I always wanted to work with industry. So what I was doing, I was working as an AI consultant or AI engineer, however, in many different companies. I have been working there for more than 7 years right now, with more than 30 production AI solutions. And currently I'm working at Info Studio. I have my own consulting company, which is working with startups called necessitating. I have been working for a long time with InfoBip and so on. So I have seen some stuff. Today I will try to give you short insights of few limitations that we had while deploying deep neural networks or some deep learning into productions. Okay, so AI is everywhere. We all know that. Why? Because everyone is talking about AI for last few years. Basically, of course, in last year, everything exploded. But there are some really important things to note about those AI solutions. So first of all, everyone talks about AI, which is something that's good for our business, and we have some more opportunities, of course, to work on those solutions. But at the same time, everyone thinks they know AI. I have seen many AI experts in last 1 year, and before that they were blockchain experts, and before that they were, you know what I'm talking about. So everyone thinks they know AI, and everyone thinks they need AI. The last point is basically something that I will try to emphasize here, just to see a few examples where, okay, AI is cool and AI is great to be used for your problems, but do you really need it for those tasks? At the same time, AI requires a lot of knowledge. So as we all know, I mean, we are all working on some AI solutions here. When we are talking about AI, you really need to know what are you doing, and it's just not enough to know a few fine-tuning hacks for large language models or some other large models. You really need to know what's happening there, at least to try to explain it to your customers what will they need for their solution. So we need a lot of knowledge. We need a lot of resources, which is something that people are mostly not talking about in today's world, because okay, Google and some other companies, they have a lot of resources. So they can use some deep models basically for everything. But when you are having some startups, when you are having some smaller companies, when you just don't have large enough budget for your AI projects, it's really important to see how can you optimize all those resources that you need, for example, for inferences and so on. So we really need a lot of resources for that. And of course, if you are using AI solution, it will drastically basically increase expenses. Okay, so what I have seen here, basically everyone wants AI, everyone wants Ferrari. They are ready to pay for it. They will give you 5,000. So is it enough? And that's something that I have encountered many times in my career until now. So they have one project for you. It's AI. You should give them a solution in next week. Is Monday okay? And of course, they will give you some money for that, and it's mostly this is proportional to what they offer you. So you really need to do your best to convince them basically to pay enough money basically for their AI solution. And I will try to give you some tricks and some case studies that I have been encountered in my career for now. So what we will discuss here, basically, do you really need AI for your solution? It's something that you really need to question about. What kind of AI do you need? Do you need deep learning? Maybe some other classic techniques which are still in the field of AI will be enough for your problem. And of course, we need to consider the cost over time. Okay, to give you some solution to production, that's one step, but you need some money to run it. You need some money to have it in your system for a longer time. Maybe something will change in the future. You will encounter some other cases and so on. So let's see what can we do on those topics. Okay. So main objective here, as we are basically here mostly engineer, is to increase development expenses, which is fine. But at the same time, we need to decrease operational costs. So if we have that system in production, how can we make it really optimal for our users and for their needs? Okay, so now we will talk about 3 case studies that I have been working on. And first of all is a simple one. It's called document classification. So what's happening there? Really simple problem for one of our clients. He basically had AI team, which were few students which were working on AI problem. And you have image taken by your mobile phone, and you need to classify 2 types of documents. So basically, you have a driving license, and then you have your personal ID in Bosnian market. So what did they do? Basically, they started with different AI solutions there. First of all, okay, they collected data, which is really hard if you are trying to collect someone's personal ID, so it's not so easy. But okay, they did well on that field. After that, they tried to implement some neural networks, of course, convolutional neural networks or some other problems like YOLO V8 or something like that. And they use, of course, TensorFlow.js for their mobile app integration and so on. What's the problem here? The problem here is basically that you have these types of images. So as you can see, one of them is red or something like that, and the other one is not. So why should we use basically AI there? Why should we use some convolutional neural networks? Why trying to be cool? Of course, we can say it's AI solution and you can implement some twerks there, but I mean, you can just compare pixels here. And that's real world example. Basically, the team were working for months on that problem, I guess 1 or 2 months. But it's still a lot of resources, and then you will still need some way basically to implement it on your mobile phone to run that neural network, which is not so easy task. So what was the solution? Of course, there we could find and analyze contours, which is something that is up there for last, I don't know, 10 years, even more. So you can find the largest contour of one color. Then you can just perform some transformation to get it like it's a scanned image, and then just compare pixels or basically do some histogram manipulations. So what will happen there if we have these images? We will just transfer it like this, so it's fine. Even there, you will not see those fingers because those license documents are basically just somewhere on the floor or on the table or something like that, so you will not have those fingers. And just to compare those pixels, you are done. This worked perfectly well. and of course, you don't need AI for problems like that. But as I already said, this is real world problem. The next one is something I like to call warehouse sales forecasting. So when we are talking about sales forecasting, it's something that's really popular nowadays. And what was the problem in our case? We had those warehouses with real goods, something like milk and Nestle and so on. And what was happening there, that they have some workers that were walking around picking those items. So you have two terms that are important there. You have something which is called stock zone, which is up there, and you have the picking zone, which is a place where you can just go around and grab those items. And if you need to pick something from the stock zone, you need to wait for the forklift. So you will call him, he will come there, he will just use half an hour to put that, that thing down, and you are done. So that was really time consuming for our workers, and they are just blocked. So they were starting with their picking, and now they need to get that item from the stock zone, so he will wait. What was the solution there? Basically, we got an idea to try to, let's say, forecast sales for day after. So if we are picking articles for today, at the beginning of the day, in the morning, we will try to predict how many items will we pick for that day, and then just use forklift. So before workers start their shift, forklifts will just go around the warehouse and just put everything down. So that's not so hard problem if we are not talking about sales forecasting. So how many items should we pick? Which is something that's really not an easy problem, and you have a lot of literature about that. So there are some standard solutions which are basically time series forecasting, but they are mostly used for months, 3 months, or something like that predictions, not for daily predictions, which is one problem there. The other problem is basically that we needed this solution for new warehouses, so we don't have a lot of data. Basically, we have a month or two of data, and then we need to predict their sales for tomorrow. Those are really large problems, basically, if you are talking about some recurrent neural networks or proper DeepR and some other architectures. So what was our solution here? Our solution here was basically just to look at the data that we have. For example, 2 months would be enough for us. And really a good thing about that is that in most of those warehouses, you have a lot of places empty, a lot of pallet places empty in the picking zone. So if that's the case, then it's okay to miss some forecasts. So if you just say, okay, you will sell 100 of those items tomorrow, and then the forklift comes and just picks down 200 or 300, it will be fine. So if you have the place, just use that place for that. And basically, our solution was just to track and analyze recent history, to include some seasonality in those problems. That was really important for us. So we had some ice creams and so on in those cases, just to see how to deal with that. And basically, we created a math formula for that, which was something like, okay, use from the last week what you have sold from last 15 days and so on, and just to find the, let's say, a perfect formula which will just give you a good enough data to implement it and to run it in production. Of course, when you have a lot of data and when you have enough data, basically, you could use those some other problems. You could use some other AI models, but for now, that formula will give you good enough solution for your customer just to run this solution in practice. And this was the result. These were the results. 97 of reduction in forklift usage just by math formula there. So we didn't have anything cool, anything let's say sophisticated, just math formula, which is something like 1 coefficient time number of articles sold in the last week and plus linear combination basically, and we got 97 of reduction in forklift usage. And what's really important there is that we got that formula much faster compared to some other sales forecasting solution that we were working on later for some other purposes, because you need to test it, you need to run it, you need to find perfect model. There are tons of them. So I mean, why? If that result is good enough, why should we basically use everything? And still, the only it worked in last 5 or 6 years, how long this formula have been used in our system, is that when we have a new warehouse, we just need to twerk a bit of that formula. It's still working really well. Of course, we have some Prophet and some other models for some more, let's say, complex sales forecasting, but for this, where we have a large safe net, basically. So if we miss, sometimes it's just fine. You will use forklift that time and that's it, or you will have some items for tomorrow. But when it's good enough, then of course it's good enough. And there is one similar problem that we have been working on for last, basically few problems. It's called how to predict unloading time. I have been working on one problem which is called vehicle routing problem. So basically you have transport management system where you have a lot of customers, their goods needs to be delivered to them, and then you have to optimize your fleet and vehicles and everything else. And we have been working on that problem for a long time, and we implemented those solutions in different companies, and every time we have the same problem. How much time will it take for all the goods to be unloaded from that truck to that customer, which is really hard. Why? First of all, you don't have enough of data. So basically, they visit one customer once in 15 or something like that, 15 days or something like that. So to collect enough data for some deep learning or something like that, it will just take years, and you don't have that time. So that's one problem. The other problem is basically, okay, you have different types of customers. If you are delivering to some large shopping centers and so on, you have to wait for a long time. Sometimes it's just crowded and so on. And if you are using for some, I don't know, smaller markets and something like that, you will just basically you will have to stop for like 30 seconds just to give them the bag to sandpapers, and that's it. So what we're doing here, we tried different models. We tried even machine learning after some time when we got enough data, but still the best results were similar to the last problem we mentioned, and basically it's just math formula. So you have which customer is large one, which customer is not large one, which customer is in the shopping center, which one is not, how much articles do you have, their mass, weight, their volume, and basically that's it. You just need to incorporate that to your formula. And that basically gave really good results, because we also used the GPS tracking system for those vehicles just to see how much do we miss, and basically it's really nothing compared to some other problems they are encountering each day. And last problem I will talk about is something that I have been working on with one startup. It's a problem of MOT, multiple object tracking, which is, let's say, similar to something that Peter was talking about in football, but you just sometimes don't have those GPS devices and those, let's say, vestas on your players, so you need to track them by computer vision. And unfortunately, I have NDA with that customer, so I will try to find different domain with the same problem just to explain what we did here. So what's the problem? It's the problem of tracking objects, which is really simple. You have one camera, which is placed in, let's say, controlled environment, and football matches are basically controlled environments. Not so controlled, but they are fine for this problem. And of course, each solution out there right now is using YOLO V8 or some other models like that, which are really working well. And everything was working really fine. You have YOLO V8, which is a neural network from one frame. It will give you all the players and everything you need from that frame. And of course, you need to associate those data. So if you have 2 frames, so the video is going, and you need to connect those objects from one frame to another frame. So what do you use there? You have some different sort algorithms, and they are all working well. But what was the problem in our case? It was really, really resource consuming, and it was not good enough for the startup purposes. So they needed to track, for example, like 10,000 of those environments at the same time. And they are trying to make some solution which is much cheaper than there is something in production right now. So they really need to optimize those resources. And with YOLO V8 and some other twerks there, you can get the tracking by real time. So basically on those GPUs, you can track all objects in real time. But we need it much, much, much faster. And what was our solution? So basically, it's something like that. You have all those players, and you need to know which one is Marcelo or something like that in each frame. You all know that game, yeah. Okay, what was our solution? Basically, we used different classical techniques in computer vision just to try to optimize GPU resources. And what we used there, we used something like, for example, we detected how much two frames were different between each other. So just by using that, you could eliminate many possible cases where you would use basically YOLO in that frame. So sometimes we will just eliminate YOLO. And of course, after that, if you are looking at the player, okay. Oh, I don't know, this one, something like that. When his bounding box is nowhere near some other bounding box, then you could simply use just, let's say, pixel tracking to see where that box moved, and that you would not use a neural network for that. And just by using few, like this, few simple, basically, solutions, we developed something that was based on YOLO V8 and classical tracking objects, and we got like 20 times faster than real time. So you could track, you don't need for 20 of those environments, you would not need 20 GPUs, you could just use one of them to track everything in real time, which is something that was just really resource saving for our clients. I will try to give you some conclusion.
Generative AI, generative AI, generative AI, AI as AI, AI. It uses AI to bring AI.
You all know that video. So this was fronting from a 15-minute speech. And of course, AI is great. I live from that, so it's really great. But at the same time, it's just really important for each and every one of us to think about few things when implementing AI solutions. You need to think about the future. So you will need a lot of money to keep it running for a longer time. You need a lot of money to implement it right now. You need a lot of resources. And of course, which is really, really important, you need real experts, basically, that will help you with that solution. So a few key takeaways. Don't just apply AI, think about what are you solving. So I like to say when someone is asking me what I'm working for my life, basically I like to say that I'm problem solver. So that was the whole my career. They have some problems and then I have to find a way to solve it. It can be AI, but it just, I need to give them solution. How good is good enough? Sometimes when people are working on their AI solution, then it's just they tend to do a lot of unnecessary work, and just to solve everything needs to be generalized, and if something changes, then it will be fine and so on. But sometimes you really have some controlled environments where there is good enough solution for that case. And of course, plan for new data, plan for new cases and everything else, and anticipate the future. So basically, try to solve problems when you really have them, or when you are sure that you will have those problems. Of course, unless you have unlimited resources, and then it's fine to work on anything else. So basically, that's it. And of course, if you have any questions, I'll be here. I don't know if you have enough time.